Thank you. So, oh, that's loud. Thank you for coming here. I know it's Sunday. It's the last talk of DerbyCon, and I know it takes a lot sometimes to show up, so we greatly appreciate you being here. So our talk, Simple Network Management, Pwnd, a pen tester's view of SNMP. My name is Deral Heiland. I work for Rapid7 as a pen tester, a consultant.
I'm Matthew Kienow. I'm an independent security researcher.
So let's go ahead and get started. So why SNMP? Why are we doing this? What's driving this project here? So me and Matthew decided earlier this year that we were wanting to do a project dealing with SNMP, obviously. But what we decided to do is do it in multiple phases. So what you're getting today is phase one. This phase one kind of focuses in on information that we can pull from devices through read-only, rewrite community strings of public and private. Basically what we're talking about is common misconfigurations, devices are fired up, and it's not being properly configured. We're also, as a consultant, and I go on sites to do work for customers, the big thing I'm always asking myself, am I actually examining their environment holistically, covering things like SNMP, and actually giving them some good feedback on the real flaws or the real risk with SNMP not being configured. So many times, you know, as consultants, and all of us do it, you go and you find a device that's not properly configured, and what do we typically do? We create a table of all the devices and we go, hey, this is bad, you shouldn't do it. Well, it doesn't really actually tell the customer the actual true risk. So the goal of this was to actually do that. So moving from there, we wanted to start examining SNMP, pulling data off these devices and figure out what are we going to get from these devices. Is it cool stuff? You're going to get to see that today. Yeah, we found some cool stuff. But moving from there, looking at Shodan statistics on the internet. There's nearly 24 million devices listed on Shodan, exposing SNMP to the internet. Now this is, from what I can tell, because sys descriptions are actually published on Shodan, that they're actually enumerating at least the read-only part of the SNMP, most likely because it's configured for public. So we're looking at 24 million devices out there. How many devices are on internal networks? Those numbers get astronomical, because every engagement I've ever been on, I always find dozens, if not hundreds of devices on corporate networks with SNMP, read-only community strings set to public, and the private ones set with private. So we're going to start off with a discussion, a high-level discussion on SNMP, and I'm turning it over to Matthew to do that.
Thank you, Daryl. So today we'd like you to move beyond thinking about SNMP as simple monitoring metrics. Let's go beyond that. So we have vendors, and they're creating new devices every day, trying to provide management solutions for that. And their clients are purchasing these devices, not only from them, but from a variety of vendors, and adding them to their network. So if you think about that, we have growing networks with a diverse collection of devices. If there's a single management, if they're independent management solutions, that's going to increase the complexity of that work, right? So there's clearly a need to simplify. Taking a simple view of network management, you have the manager. Now, the manager is a system that is responsible for managing and monitoring network elements. And a network element, now this is any device that is capable of running the TCP/IP suite. This could be anything from servers and workstations to printers, cable modems, even routers. And an agent is a software system that runs on that network element. It keeps track of the values of various variables related to the logical subsystems on that device, and it tracks the values. It also handles updating them and stores them in a local database. Now, what does communication look like between the manager and the agent? Well, the manager can read or update the value of variables, and the agent reports information back to the manager. Simplifying that communication, we form a protocol, and this allows devices from a diverse collection of vendors to communicate with each other. So now you have vendors creating devices with agents on them and different managers, and they can now communicate with each other. The transport protocol is typically UDP, although other transport protocols could be used. It was not specified strictly in the RFC. Under the UDP transport model, agents listen for requests on port 161, and managers listen for traps on port 162. Version 1 of the protocol introduced 5 major messages. Those can be divided into 2 categories, those from the manager to the agent, and those from the agent to the manager. The GetRequest message is used to get the value of one or more variables from an agent. Let's take a closer look at how that might work. Let's say the manager wants to get the value of the system description and system uptime from the router. The manager is first going to create a GetRequest message. This message shares a common PDO format. Up at the top in green, you'll note the SNMP header. Important to note here is the community. This is the clear text value that's used for authentication. The center portion in blue represents the get set header, and the portion at the bottom in magenta, this is the variable bindings list. This contains a list of variables, either being get or set. So in the case of the manager getting the value of those 2 values from the agent on the router, the object 1 will contain the variable for system description, and variable 2 would be system uptime. Right? Now the manager is now going to send that message to the router. When the agent on the router receives that, it's going to look up the value of those 2 variables in its local database, and it's going to create a get response message. Now this message shares the same form as the message we just looked at, with the exception now the variable bindings list will contain the value of those 2 variables in the variable binding list. The agent's going to send that message back to the manager, and it can do what it wants now with that information. And the get next request message is used to get the value of the next variable. This is based on lexicographical ordering of the MIB table. This is commonly used for navigating through tables, for instance, routing or interface tables on that device. The set request message is used to set the value of one or more variables on the agent. And moving on to the 4th, this is the agent to manager. Now, in response to those first 3 messages, the agent responds with a get response. This carries back the value of one or more variables. Now, the 5th message type does not follow the same form as the other 4. This is the trap message. This is used by the agent to notify the manager of an abnormal condition. If you think about situations otherwise, the manager would have to continually be polling the agent for this information, but that's not really efficient, right? So if something were to happen on the particular device, the device can notify that manager of that event without waiting to be polled. Let's take a closer look at how that might work. So let's say the agent on the router identifies a failure in one of its communication links. One of them goes down. So the agent's going to create a trap message, and it has this format. Again, you'll see the SNMP header at top, and the portion in the center is the trap header. Important to note here is the trap type. That will be 2 in this case, which represents the generic type link down, indicating that a link went down. The variable bindings list in this situation will contain the variable for the interface index and then the value of the specific index that went down. The agent then sends the message to the manager, notifying it of that abnormal condition. Moving on to version 2, it's very similar to version 1 with a few major enhancements. Number 1, there were 2 new messages added. First was get bulk request. This allows efficient retrieval of a large number of variables from the agent, whereas before, we would have to use the get next message and continually navigate through the MIB structure. We can now request all of those, or a large portion of them, with a single request. And the inform request, which is an acknowledge event notification, this is commonly used for manager-to-manager communication, as well as providing an acknowledge trap. So if we look back to version 1, when we use the trap, the agent was unaware of whether or not the manager received that message. But in this case, the agent can now send an inform request and be getting acknowledgement whether or not the manager received that message. 2 new MIBs were defined. This also revolves around managed or manager communication. And there were some security enhancements provided. Partially, the party-based and community-based models were introduced, although due to the complexity, they were not as widely adopted as 2C, which provides the same security as version 1, again, the clear text community string. Version 3 finally provided an enhanced security model where we now have authentication, encryption, and integrity, as well as providing access control over those specific variables. And there were some changes made to facilitate remote configuration and administration of entities. I'm going to turn it over to Deral. He'll talk to you about OIDs and MIBs.
Thank you, Matthew. So as Matthew discussed at a high level the TCP/IP protocol, he mentioned a couple terms. One was the OID, Object Identifier, and also the MIB, the Management Information Base. Real simple. The Management Information Base is basically a database. This is a database of information that exists on the agent or the device. The OID, the Object Identifier, is the ability to retrieve that. It is a number sequence to identify locations within that database where you can retrieve the data. Also on the Management Information Base, you can retrieve or you can get what's known as a MIB file from a vendor. The MIB file is nothing but a simple text file that you install on your management tool product that'll help identify the data associated with that particular manufacturer's product within the MIB. So the OID is nothing but a simple, universally unique numbering system. As we see there, 1.3.6.1.2.1. We can also reference it by name. So if you look in the lower part of the screen there, we see the ISO org DOD all the way out, and that's the same thing. Typically, I do not like names. I like numbers. So throughout this presentation, I'm going to focus on the numbers because I can actually remember that crap. So moving from there, here is it's in a tree structure. This kind of lays it out so you kind of understand that model. We see we got the 1.3.6.1, and then below that we have the directory, the management, the experimental, and the private. The one of most interest of the work we've done is the private enterprise. So 1.3.6.1.4.1. You got it all memorized now? Okay, just checking. And below that, you have individual manufacturer numbers that make up their private enterprise MIBs. And these are actually assigned through IANA, the Internet Assigned Numbering Authority. And you can go out as a business and request one of these numbers, which is what I did. So Matthew, you know what my number is?
Yeah, I do.
You weren't supposed to say I do. Okay, the number I have assigned is 43555. So if you're ever enumerating a device in the future, and you enumerate with the 1.3.1.6.1.4.1 43555, my advice is don't go any further. Shut your device down, and you may have to reformat everything if I didn't do it for you. So just be aware. We haven't started using it yet, but we have some ideas. So here's a list, a sample list of some of the private MIB numbers that are out there. As we see, we have IBM, Cisco, Hewlett-Packard, and the list goes down, and there's some cable modems at the bottom there. So we can see how that structure is actually laid out. So this happens to be a walk, an SNMP walk of a device. Now, what device is this? Who made this device? Does anyone know? HP, yes. If you notice on the last table, 11, the 1.3.6.1.4.1.11 is the private MIB, private enterprise MIB for Hewlett-Packard. So when we query the data using the OID that's on the left-hand side, we get back the data after the equal. That's what will actually get returned to us from the MIB. But if we want to be able to identify that data, we're going to go out and get Hewlett-Packard's enterprise MIB text file, install in our manager. And what it'll do is it'll give us the ability to identify those fields within our management application. And the top one turns out to be the model number, and the lower one happens to be the configured IP address on the device. So it's fairly straightforward and simple. So now that we've covered the SNMP protocol at a high level, we understand the OID, the MIBs, let's get into hacking some stuff. So we found some real interesting things on Soho devices. I'm going to turn this over to Matthew, and he's going to introduce you to some of the issues we discovered.
All right, so we started our first phase research using Soho devices because they're easily obtainable at a low cost, both on the used and new markets, right? We focused on cable and DSL modems primarily because these came with SNMP enabled typically. First wave could be divided into two categories mostly, Netopia, Motorola Aries. The Netopia was purchased by Motorola, and Motorola recently sold off their cable modem division to Aries. The same thing occurred with Ambit Ubi. Ambit was purchased by Ubi. Moving on. So one of those devices was the Motorola 3347. We found that this device gives up its wireless, both WEP and WPA pre-share key information via SNMP public by default, in addition to SSID. And it's important to note that all this is an older device. Shodan currently shows over 100,000 of these being used, exposing SNMP public to the internet. The Ubi DD-W3611 also has the same wireless exposure of information. In addition, here we have the username and password for the device interface being exposed. Let's do a quick demo of this. So the process, during that research, the process often involved using SNMP walk, and you're dealing with large dumps of information, and often the values we were interested in would jump out at us. But we wanted to save everyone some time since we already did the research, and we built some SNMP scanner modules for Metasploit so everyone can have fun if they encounter these devices. All right, so I'm going to load up the scanner for the Netopia. We're going to quickly take a look at the options and note that all we need to configure here right now is the rhost. So we're going to set rhost to the IP of the Netopia on our little LAN up here.
We have a whole bag of modems here turned on.
And we run the module, and quickly we get the SSID, as you can see right here. And we see that the device is configured for WPA, and the pre-share key is there in clear text. And it was available via public community by default.
And there's over 100, like you mentioned, there's over 100,000 of these actually exposed on the internet.
Based on Shodan statistics. And we'll quickly load up the module we have for the UBI. Same thing, take a quick look at the options. Again, we know rhost, so we'll set the rhost. And run the module. In this case, we see that this user happens to be using WEP. Okay, that's fine. But we have all of their WEP keys in addition to knowing which index actual key is in use. But in this case, the device is also giving us the username and password for the device interface, so we could log into their wireless, and, well, in this case, we're actually on the same network, but we could actually log into the device and play around with its configuration. So what we found was that devices that have wireless on them tend to expose sensitive information related to that wireless subsystem. Now, the risks are there for home users, but we also have to consider small businesses because many small satellite offices commonly use this sort of Soho-grade hardware in their offices. So if we were able to obtain the IP address for one of these satellite offices, we could query the information, assuming that it is exposing information exposure via SNMP public community, and we could take the wireless key information, take a trip to their parking lot, jump on their Wi-Fi. Now we have access to the satellite office network, and we could use that to leverage into the greater corporate network. I'm going to turn it over to Deral, and he's going to talk about targeted attacks.
Okay, so you see, we found some interesting stuff, and we found quite a few different modems. We'll discuss those in whole here in just a minute. But from a targeted attack standpoint, is how could I use this as a targeted attack? So I was thinking this through and did a little research, and we just got a little scenario. So let's say I wanted to target a city location. Now, what would I want to target a city location? Well, let's suppose I'm traveling somewhere, and I actually want to steal the data. Let's pick a city. Let's say Louisville. Very coincidental, huh? So we go from there, and we do a Shodan search, and we find that there is the city of Louisville. Let's take a closer look at this. Turns out the city of Louisville is the top city in the United States exposing SNMP to the internet. So we did a little research. I went out. There was 50,000 of these devices. So we went out and decided to, let's grab some of these type of devices that we would want to gain access so we can get like free access. So it turns out we already had the Notopia. We'd already discovered that one. So we had that piece of data. So I went out and bought a couple other modems that were available there. One of them happened to be a DG950A Aries device. And it turned out that there happened to be 1,600 of these devices in Louisville. So between the two of those, we've identified 2,600 devices that are part of the city of Louisville that you can gather the WPA web keys, passwords from these remotely over the internet. In this case here, the same issues. There's the OIDs for querying that data off those devices. So let's go on a bigger level. So what if we wanted to target a country? I'm traveling international, you know, and I suffer from not caring about the law. I have no ethics. You know, those things come into play there. This is something I would not advise somebody to do. But let's say we pick a country. Let's try the country of Turkey. That way, if you do get caught, they can like hang you in some prison and beat you with sticks. So we start with Turkey. We go to Shodan and we search, and we find out that there is literally 1.2 million devices exposing SNMP, read-only community string of public to the actual internet, according to Shodan. We got one of the devices, we did some testing, and we found this one right here, the CBW700N, which is a Netmaster device. Turns out that device is exposing 275,000 to the internet. Again, the same information. We get the usernames, the password, the SSID, the web keys, and the WPA keys over the internet, potentially to 275,000 devices in the country of Turkey. So out of all the modems that we've actually gone through and that we've looked at, here they are all listed. Every one of these modems suffer from what we just showed you. So I think we're really just scratching the surface here. I expect there's probably dozens and dozens more of different models that could potentially be exposing this type of data. If you want to read up on these, you can go to, oh, I forgot about that. Out of these devices, according to Shodan, there's 496,000 systems within these device ranges where you can pull the web keys, WPA keys, the device's usernames and passwords in a number of cases remotely over the internet. Here is some quick links if you want to look at the actual advisories that were published on these. So we made these advisories on the Rapid7 site, and one of them was just published on Full Disclosure by Matthew. So why so many DSL modems? You know, this is kind of a hard one. Well, it turns out that the ISPs are generally managing these devices with SNMP. It's how they're managing it. Historically, they weren't doing it safely or securely, so that they were actually using the default read-only, a public, the read-write community string, a private to manage these devices. So in the United States, we're seeing these numbers decrease of the amount of exposures out there, predominantly because a number of these devices are being aged out that are in homes. And as soon as they, get rid of it and put a new one in, the next one coming in is configured correctly. Now, I still think they're probably leveraging SNMP for managing the devices, but yet they're setting more complex public read-write community strings so that that we and other people out there can't get free access to these devices and steal information. But on the other hand, looking at some of the numbers in foreign countries and some of the devices we found, like here in the U.S., Netopia had a little over 100,000 devices, but generally we're seeing 40,000, 20,000, 15,000, smaller numbers. But when we look at some of the devices that are found in other countries like Asia areas, also South America, Central America, we're not seeing those low numbers. We're seeing 100, 200, 300,000 devices that are actually exposed by a specific series of ISPs in those locations. So it's pretty significant. So moving from there, we're going to go ahead and turn this over to Matthew. No, I'm sorry. I will not turn this over to Matthew. Oh, yeah. Hold on. This was a demo. So I got sort of kind of a demo. Hold that for me. So I'm going to go ahead and log on to this device. Oh, shit. Not paying attention. Damn, how many times have you done that? How many people often do that? You go to log on to the device, and damn, you put in the password, and what do? I mean, most of the time, I just go on. I correct myself, and I move on. What kind of data are you leaving out there? Well, it turns out that a number of devices, specifically embedded devices, actually store parts of the logs within the MIB data that could be queried over SNMP to a device if you know the community string, which we know misconfigurations or not being configured at all is a very common factor. So we see a very large number of devices in an organization where this data is actually like this. So just looking at this log data, here's some key things you can potentially get. If it's a successful logon that they had, one, you can actually get the username that they logged on the device with that you could do brute forcing. We can also identify the host they came from in most of the logs, so you have that information. And if it's a failed logon, just like I did, you could potentially get the actual password. And we know the next logon they do is going to be the right username. So now you have the username and the password to gain access. And if you've seen anything I've done in the past, hey, what's nothing better than actually injecting cross-site scripts into their logs? So the next time they decide they want to view their logs with a web browser, you'll own them. So I'm going to turn this over to Matthew, and he's going to show you the damage that I did and show you some stuff associated with that.
All right, so while researching this device, as Deral mentioned, we found that it was storing a portion of the log in the SNMP table. This is found using SNMP walk. Often when we run the command, you'll get a large dump of information back, but when there's a block of text, it's usually quite obvious when scrolling through that information. So just quickly save some time. So what we're going to do is use the SNMP walk command. We're going to configure it for version 1 of the protocol. We're going to tell it to use the public community string. Here's the IP address of the particular device, followed by the MIB of interest, the OID of interest that actually contains a portion of the log. Running that command, we see that it quickly dumps log information. And if we look at the very last entry, we see Daryl's failed login attempt, as well as the host that he attempted to log in from. So if we're to look at subsequent entries or entries earlier in the log, we might find the username. So now we have a username and password. We have all the hosts that the administrator of this device might be logging in from. So it's a quick way to gain some information about the network here. So when we encounter a device on a pen test, we should remember to always check if SNMP is enabled and it's accessible. If it is, we should walk that device, or SNMP bulk walk that device, capture that information, and analyze it prior to launching brute force attacks against the device, because we might wipe valuable information that could end up saving us time. A quick way to analyze that information, we could run grep commands, or express regular expressions to grab things like of interest, like admin, password, IP addresses, etc. I'm going to turn over to Deral. He's going to talk about an enterprise Brocade load balancer.
Okay, so far we've talked about SOHO-type devices, and we talked a little bit about some things you could do when you're on an assessment to actually potentially retrieve passwords by at least examining some of these logs for key data. But we're going to talk about a Brocade load balancer. It turns out, during an assessment that I was on, a company had a Brocade load balancer. It happened to be a server iron ADX, actually exposed to the internet. Well, that's what it's there for, is a application load balancer. But they had exposed SNMP also. This device, out of the box, default, has SNMP enabled. So if you put it straight out on the internet, it's going to have SNMP enabled out on the internet interface. Right now, there's about 800 or 900 of these devices listed in Shodan. But during this assessment, what I did was I dumped it over the internet, did an SNMP walk, and then I searched the data, like Matthew had talked about, looking for keywords, admin, root, things like that. And I got a hit on admin. And a number of devices I've looked at in the past, when you see things like that, and it's not in the logs, but it's part of the actual MIB, it's not uncommon in some cases to actually find passwords in there. So I'm thinking, oh, maybe I'll find a password. Well, I searched down there. I looked at the next line. Turned out it was a string, and it started with $1. So instantly it's like, hey, I think I have a hash here. Threw it into a password cracker. After about 4 hours, it dumped out the password. And I was able to log on with admin privileges over the internet on this device by pulling the data through the SNMP. We actually also have a Metasploit module in Metasploit now for that. It'd be nice to do a live demo of it. Unfortunately, no one's going to lend me a $12,000 device to come here and play with in front of you. So, as we look at the screen right here, I don't know if this pointer will work or not. I guess it does. So the cool thing when we're looking at this is we get all the usernames. So if they've configured the device with multiple usernames and not the default out-of-the-box admin account, but they have all the people they work there as network infrastructure or admins or whatever, instantly we have all those names identified, and if we crack these, we're not only going to get the Brocade load balancer in this time here, you're more than likely you're going to get access to all their network infrastructure devices, because these admins all are going to have the routers, the switches, the firewalls. More than likely they're going to have access. So it can get quite significant at that point, and you can go pretty far with it. So I'm going to turn it over to Matthew, and he's going to start off with some other data points of interest.
All right, so while doing this research, we decided to just take a look around what else SNMP could be used for. As you all probably recall, over the past 2 years, there's been a lot of noise created about NTP and DNS, distributed denial of service attacks. SNMP could be used for the same, although it wasn't getting as much attention as the other two. The earliest identified distributed or denial of service proof of concept dates to 2005. It's available on Packetstorm Security. Now this works because UDP is a connectionless protocol, and the attacker can spoof the IP address. So that response to the, in this case, a get bulk request message can be directed to the target. Now, if you recall when I talked about version 2, the get bulk request message allowed for efficient retrieval of a large number of variables. Well, that's really useful if you're efficiently retrieving those and directing them to a target. One white paper exploring this topic found a 1 to 3 request to response ratio size, and upwards to a 1 to 7 ratio. And that's just that's just using one agent. So if we think about the numbers we've seen of devices exposing SNMP via public to the internet, that's a large number that could be used to distribute that attack.
So a couple other items that are interesting, and this is dealing with the actual read-only and read-write community strings actually often being found within the MIB tables through the read-only. So I've come across a number of devices where if by chance during an assessment I get the read-only community string, and of course golden is the read-write community string, especially if you're dealing with a Cisco environment. Because most of us should know, if we don't know, that you can pull the running configs off a Cisco device, standard iOS device, with a read-write community string. You can tell it to TFTP the config to you. And there's a Metasploit module for that. So that's golden. That's what we want. So what happens when I get the read-only? And this has happened to me several times. Well, what I do is if I just have the read-only, I can go out and look at a number of devices. It can be anything from cameras, IP cameras, down to UPS devices. There's a whole list of devices out there. And I assure you, once you've checked through 3, 4, 5 different types of devices, you will find one of them. When you find the read-only, when you search the SNMP walk data, and you search for the read that you have, the next one in line will be the read-write community string. And now you've hit gold. Now you're able to go to the Cisco environment, if that's what they're running, and pull all that data and get the running config. So it's kind of important. Some of the other things you can do with this, and to me this plays much better during external assessments. If you come across an infrastructure device that's been improperly configured, a router or something that's nature, it's not uncommon that you can get enough information dealing with the network infrastructure design, because it's going to show the routes, it's going to show the VLANs, it's going to show all that data within the MIB data. So it's easy enough to get yourself a SNMP management tool, go to the company that owns that device and get yourself the MIB text file, install it on your device. That way it can interpret that data, and now you can pull that data down and map out a key structure, key parts of their internet-facing infrastructure.
All right, so now that we know a number of risks that are associated with SNMP, what can we do to mitigate the risk? Well, first, manufacturers should disable SNMP by default. And if it comes enabled, then they should move away from using public-private as the read-only, read-write strings by default. They should also move away from version 1 and 2C, since those are using the clear text community string, in favor of version 3's stronger security models. And MIB objects should not contain sensitive information. We shouldn't see passwords, password hashes, security keys, etc. in these. This should be data that's related to the operational parameters of the device, of the various logical subsystems on it. Deral, what should end users do?
Just as Matthew had said there, the manufacturer should, by default, make the device disable SNMP, but they don't. So you're responsible for that part. So as an organization, company, one of the key things you probably need to do is build processes around implementing devices in your environment. And one of the key things should be that the device's SNMP, if not being used, is disabled on the device prior to it being rolled into production. The second thing is public and private should not be the same. You know, that's like going in there and taking half the people in the Active Directory environment and just give them the domain admin password to use for their password. You wouldn't do that, would you? So why would you take two items? One, you can read data. The other, you can actually write and reconfigure the device and use the same community strings. Next, you should have it should be treated as a complex password. The community string shouldn't be obviously left at public and private, but they shouldn't be simple dictionary words. And they also shouldn't be, as an example, you know, the company name followed by RWRO, you know. Because that's the first one I'm going to try. So we need to set these and make, I recommend 20 plus characters. You can go longer than that. Put as many in there as it'll take. Because remember, this isn't something that you got to use, that you need to remember. This is something you put in your management tool for managing everything. So it doesn't need to be something that's easy to remember. It should be complex and not easy to remember. That way you can prevent easy brute force guessing of that. And the big one right down here, SNMP community strings should differ based on the security level of the device. An IP camera and your Cisco's routers, firewall devices should not be at the same security level. So they should not have the same community string. The first attack I do when I go into organization and I decide to attack their infrastructure, I go after, and they're a big SNMP shop, I go find the UPSs, things like Liebert UPSs, ADP UPSs, and they've configured all these for, as an example, they've configured all the ADPs to use SNMP, but I can almost assure you they never changed the password on every one of them from APC. So APC, I'm into a UPS device, and now I can pull the read-write community strings that are there, and now I can go in and attack your router switches and firewalls and pull all those running configs. This is an attack I do almost on every engagement when I'm dealing with SNMP shops. So that kind of concludes our presentation. Do we have any questions? I am not aware of any. Does anyone know any? Does anyone here know of any documented best practices out there? Our goal here was to start that definition. That's why we did this. I personally couldn't find anything, and we sat down and go, well, let's define it here. Here we are. Let's define what should be acceptable practices, best practices for SNMP. If anyone has suggestions for changing this or what you think it should be, email me. Got my email address up there, right? Email me. Give me some suggestions, because we can continue pushing this as a best practice standard out there on dealing with SNMP. If you think some stuff here should be taken off or better worded, please do that, because let's build a standard that can be used. Other question?
No, bulk walk. So SNMP walk uses the get next request message, and then bulk walk uses the to get bulk request message. So it's just you leveraging the two different messages. Absolutely. That's actually a really good question. I'm not sure if it's a part of the same net SNMP suite.
It's part of the protocol.
They're talking about the tool.
Oh, the tool. Okay.
So what's the prevalence of most organizations in pen tests doing proper route filtering, firewall controls internally to make sure SNMP is not abused, but also putting controls on end devices? I mean, how do manufacturers support something similar to Cisco's filters for what MIBs you can pull or even what IPs they can pull from?
I'm not sure how to answer that. Yes. So how many people work in a shop that uses SNMP, just out of curiosity? So how many of you guys use version 3? Okay, so there is a few. It does exist. Can you take a picture and send it? I'm not seeing version 3 implemented at this point in very few places. So it's kind of a privilege to actually see some people. Sorry I didn't have an answer for your questions. So any other questions? Yes, sir. Yes. Okay. Just to give you a breakdown of where we're going next. So we looked at the protocols. We haven't analyzed the protocols from an attack method. We're just trying to learn the basis of how everything works. We're looking for information and leakage type stuff. That's where we're at now. The next phase is using SNMP, including SNMP traps, as a potential injection attack method into systems or devices. That's where our mind's at, and that's where we're hoping to go next. Yes, sir. As in the protocol? Yeah, we're probably going to do that. That's on the list of things I think we're planning on doing, but we have not done that yet. I am personally not aware of any SNMP protocol issues yet. I know there's probably been research in the past. I don't expect I'm the first one to go, hey, can I screw with SNMP? I'm sure I'm not. Okay? So if anyone ever comes across any papers out there where someone has done some SNMP fuzzing, even if it's years ago, where they actually found something, I would love to see those. So if anyone's aware of something like that, please send it to us.
But to touch base with the other side of his question, potentially, I think you were asking whether or not it's a single library or multiple libraries being used. I would imagine it's a combination of both. Okay.
I think that pretty much finishes the talk. I think we're out of time now. Thank you very much. We appreciate it.